Hey everyone, today we're going to take a look at ArgoCD. So ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. Essentially what it's going to allow us to do is it's going to allow us to define all of our infrastructure and applications that run in a given Kubernetes cluster and define all of that in a YAML format that is Git controlled. And then what we can do is we can set our Kubernetes cluster to stay synced to that GitHub repo so that whenever we push new changes to it, our Kubernetes cluster automatically stays in sync with it. And this is super useful because we can do things like, for example, go ahead and I have a Kubernetes cluster right now that is currently running ArgoCD and has deployed a Redis cluster into it. So you can see here, I'm getting pods in the Redis namespace. So I have a Redis namespace, and if I go ahead and just delete the namespace Redis, for example, by accident, normally this might be a huge pain. I'm going to have to go ahead and set it all back up again. However, now if I go ahead immediately after deleting my Redis namespace and get it again, you can see it's automatically reappeared 6 seconds ago. And if I look and see what's inside of it now, well, we'll be amazed to find that we actually have new Redis pods already starting up. The reason why this is happening is because I've defined Redis here as an application or a Helm chart that I'm tracking in my ArgoCD GitHub repository. So my environment has detected a difference and is automatically synchronizing to redeploy it. So ArgoCD makes managing Kubernetes clusters so much easier and really gives you a level of continuous delivery from not only the application level in your software, but also at the infrastructure level, which is really great to have. So in this video, we're not only going to look at setting up ArgoCD locally and make sure that we track our own projects, as well as external Helm charts like Redis. We'll go ahead and track our own application that's running in our own GitHub repository called Node.js Concepts, which is our own custom Helm chart. And we'll actually override values inside of this Redis application. So you can see all of the resources that ArgoCD is tracking here in this nice tree format. We'll be able to actually override the parameters we're providing to the Helm chart in our ArgoCD app. Finally, I'm going to show you how we can use ArgoCD Image Updater to automatically watch our Docker repositories and redeploy our Kubernetes pods whenever a newer Docker image is pushed up to our repository so that our Kubernetes cluster is always going to be running the latest version of our code, and we're really going to have continuous delivery in this way. It's really great. Finally, I'm going to show you how to deploy this ArgoCD on AWS EKS Elastic Kubernetes Service. So we're actually going to deploy this into production, and I'm going to show you how we can run a real Kubernetes cluster with it. So I'm super excited to go ahead and get started. Let's jump right in. Hey everyone, today I wanted to bring you a new lecture on ArgoCD. So ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. So it's a very popular tool that tries to simplify the process of managing our Kubernetes clusters. So I'm on their docs right now, so you can see argo-cd.readthedocs.io, and we can see here a little blurb about why ArgoCD. So the whole premise is that it's going to allow us to define app configurations and environments in a declarative and version controlled way. Now this is going to follow the GitOps model where all of our changes to our underlying infrastructure will be tracked by our actual GitHub commits. Now this is a super useful paradigm in Kubernetes because if we are to actually mess our environment up or need to move the environment, well, all of our resources will actually be in version control already. So it's going to be super easy to go back to any state at any point. And this is one of the big benefits of using ArgoCD to manage our Kubernetes resources. So in this video today, I want to jump through a demonstration of how we can get ArgoCD up and running and actually managing a Kubernetes cluster for us so that we can see the benefits of using it to actually manage our environments. So let's go ahead and get started. So on the ArgoCD docs, you can see that they have a super simple quick start to actually get started. So we're going to go ahead and copy both of these commands to create a namespace, ArgoCD, and apply a install.yaml, which is all of the resources that ArgoCD needs to get installed. So we are actually installing ArgoCD directly into our Kubernetes cluster that we want it to manage. Now, of course, you need to have a Kubernetes cluster to access and kubectl configured. So if you don't already have Kubernetes running, you can simply install Docker Desktop and enable Kubernetes on it. I will leave a link below where you can learn more about setting that up. Now, if you're more interested in learning about ArgoCD and how it works, simply follow the documentation below to get more detailed explanation of what's going on underneath the hood. Otherwise, if you want to just go ahead and get started and get your hands dirty, simply copy these commands in the quick start and head to your terminal. So before we jump in, I want to share with you my new membership website, which has just launched. So on this website, you can sign up to become a member, and every month you're going to get access to exclusive membership-only lectures, including the code for those lectures. You're going to get a new lecture every month. Additionally, you're going to get access to all new content as early as possible, and you're going to gain access to community forums where I want to develop a community of like-minded developers to discuss full stack development, as well as discussing lectures that are released and requests for future videos. So for example, if you like today's video on ArgoCD and continuous delivery, if you sign up to become a member, you instantly gain access to another lecture where we dive deeper into this topic and deploy ArgoCD on AWS and even set up an automatic Docker image updater so that whenever we push changes to our Docker image, our Kubernetes cluster will always deploy the latest version, giving us a true continuous delivery process. If that all sounds good to you, I'll leave a link in the description where you can sign up and learn more. So back in my terminal now, I have my Kubernetes cluster running and kubectl configured with Docker Desktop. So I'm going to run kubectl get namespaces, and we can see the simple default namespaces out of the box with a Kubernetes cluster. So I don't have anything running in our cluster yet. However, I now want to install ArgoCD so that I can specify the applications inside of this cluster and have ArgoCD manage. So we'll make sure we have these two commands copied to create the ArgoCD namespace and install all of the necessary resources into it with the subsequent command. So after we've created all of these resources, we can now run get namespaces again, and of course see our ArgoCD namespace, so we can check to see what is actually inside of it. And now we can see we have all of these ArgoCD resources or pods running inside of this namespace. Now next up, I've gone back to the ArgoCD docs and I've clicked on the getting started link. So we have the first instruction to install Argo, which we've already done. So I'll scroll down to the next instruction where we're told to actually install ArgoCD. So in my case, I'm using Mac, and I'm going to use brew to install the ArgoCD CLI. If you're using a different system, you can read more instructions on the installation in the above link. However, for me, I'm going to copy the ArgoCD CLI installation command, and I'll go back and paste this in to install ArgoCD command line. So after you've installed this, we're going to go ahead and copy the command to port forward traffic on ArgoCD service on our local machine on port 8080. So this port forwarding is going to allow us to actually forward traffic into our Kubernetes cluster and into the ArgoCD server service, which is going to expose the UI of ArgoCD. So let's copy this command, and now I'll go back to the terminal and paste it in to port forward traffic on our local machine at 8080 into the ArgoCD server service. So now at this point, you should be able to navigate to localhost 8080 on your browser, and you might get some CORS error about insecure traffic. Of course, don't worry about this since we know that we're the ones serving this traffic. we can proceed to localhost. And now we are at the ArgoCD server UI. So by default, everything in Argo is password protected. So of course we can't modify our Kubernetes cluster without authentication. So you can go ahead and log in with details here. And to actually obtain these, we can go back to the docs, and the next step tells us we can log in using the CLI. So we have a default admin account, and that admin account has an initial secret password that was created as a secret in our Kubernetes ArgoCD namespace. So we can simply fetch this password using the ArgoCD CLI. We'll simply copy this command. In a new terminal, I'll go ahead and paste it in. So this is going to go ahead and give us the one-time admin password that we can copy and use to now log in. We can, of course, then change it using the subsequent command here that the ArgoCD CLI has recommended. So now that we have the password from the ArgoCD CLI, we can enter in our admin username and paste in that password from the command line. So after signing into the application, you can see we're now brought back to the dashboard. So this is where all of our applications that ArgoCD is managing for us in our Kubernetes cluster will appear here on the central dashboard. However, of course, we don't have any applications yet. We haven't configured our ArgoCD apps. So let's go ahead and do that in the next step. Okay, so I've gone ahead and opened up VS Code inside of a new empty folder, and that's because I want to actually now create our actual ArgoCD applications. So as I mentioned at the beginning of the video, everything in ArgoCD is under version control, and that includes the applications that we deploy with it. So we're going to go ahead and now specify those. So to do so, we're going to follow a model in ArgoCD known as the app of apps model. So in this model, we actually define a separate new dedicated application specifically just to host all of the sub apps in our Kubernetes cluster. So this is going to become more clear as we start building this out. Let's go ahead and do that. The first thing I want to do is create a new folder called EMS. So EMS is going to contain all of the different environments that we could potentially deploy these ArgoCD resources to. However, we could change and tweak parameters for each given environment. For example, we could have separate environments for staging and production and provide different configuration parameters to each one. Inside of here, I'm simply going to keep it simple and start off with a single environment and call this environment default. So let's create a default folder inside of EMS. And then I'll simply create a default.yaml in this default folder. So this YAML file is going to act as this app of apps manifest that I mentioned earlier that's going to lay out to ArgoCD where it can actually find all of the other sub apps for our cluster. So let's go ahead and get started with defining this. So this is going to look very similar to just any other Kubernetes resource. It's an ArgoCD application. We have to define an API version, and we'll set this equal to argoproj.io/v1 alpha 1. Then we have a kind, so this is just a Kubernetes resource. So it's an application type from ArgoCD, and this corresponds to the same application that we saw earlier in this dashboard. We're creating this root application that's going to host all of our other apps. Now we'll provide some metadata, give it a name of default, and the namespace, it's going to live inside of the ArgoCD namespace, and that's because we want to keep it scoped to ArgoCD as this is the root application. And then we have the spec for the app. So the first thing is the actual destination, and this is where the Kubernetes server is actually listening on. We'll specify the namespace is ArgoCD, where ArgoCD lives, and the actual Kubernetes server is going to be https://kubernetes.default.service. And make sure to correct this typo. This should be destination here. Next up, we'll specify the project where this ArgoCD application lives. By default, ArgoCD will create a default project in our installation, so we'll just reference that default project. So next up, we need to tell ArgoCD where it can actually look for these sub apps or the rest of the apps in our cluster that we want it to deploy. So to do this, we can provide a source block, and in here we'll specify an actual directory we want it to go inside of and look for. So in our case, I want to set this also to recurse true, so it's going to be a recursive directory search. And so by default, the directory we now provide to this source, it's going to look for any other application types that exist inside of it and automatically create them and synchronize them to our Kubernetes cluster. So now we'll simply pass a path of m/default. So I'm actually referencing our existing path in our folder here. So we're in m/default. This is where I want ArgoCD to actually look for any other applications we have to deploy. Now then, of course, we need to actually tell ArgoCD the GitHub repo URL where it looks for these actual apps. So in our case, this is going to be the GitHub URL we deploy this newly created folder to. Well, we don't have this yet, so let's go ahead and save our current YAML and go ahead and now create a new GitHub repository. So inside of our project, I'll run git init to initialize a new Git project. Now I've gone into the GitHub UI to actually create a new GitHub repository, and I'll simply copy these existing lines to hook up our repo to our local repo. So after I've done that, I'll simply run git add and git commit to actually commit our changes. And finally, I'm going to go ahead and run git push set upstream origin main to push our changes. So now if I go back to our git repo and refresh, you can see we have our m/default folder, and we have our default YAML, which is currently only half finished. But now we actually have a GitHub URL that we can provide to ArgoCD to look for our sub apps. So let's simply copy the GitHub URL that we've just created up top, and now I'll paste in the repo URL into this repo URL key. So again, this is telling ArgoCD to look at this GitHub repository, which is the existing project we're looking at now, and look into m/default recursively for any other applications that live in this folder. Finally, we also want to specify the target revision for this lookup, and this just specifies what branch or tag to use when looking for this folder. So this is really powerful. We can have separate revisions for different environments, for example, and change this target revision when we want to update our Kubernetes cluster depending on the resources we want. In our case, we'll keep everything on the main branch. So this is everything we need to actually deploy our application. I simply want to go ahead and now also add a sync policy block. And this is going to allow us to define settings for the ArgoCD sync. Now, a sync in ArgoCD is how we actually synchronize our changes in GitHub to our Kubernetes cluster. So that actual process of making the two equal is called a synchronization or a sync in ArgoCD. And now we can specify options for this sync. So for this automated block, I want to create automated and set prune to true and self-heal to true. So this is going to make sure that we automatically delete or fix any problems with our Kubernetes resources if our Git repo says that it's out of date. So this is just going to be a simple cleanup options. And then I also want sync options to be defined. And then I'll go ahead and specify -create namespace equals true. And so this is just going to tell Argo to automatically create the namespace for this application if it doesn't exist. And this namespace is the destination namespace where this app is being created inside of. In our case, ArgoCD will already exist, but I want to specify this just in case. So now our default app of apps is set up. Let's go ahead and commit this change to our repository so that our ArgoCD deployment can now pick this up. So now back in our ArgoCD UI, I'm going to go ahead and click on Create Application. We need to actually manually create this first bootstrapping app of apps, and then all of the sub apps that it watches will automatically be synced to our GitHub repository. But of course, we need to now tell ArgoCD about this very first one. So to do this, we're going to go ahead and fill in the same exact details we've just declared in our YAML inside of this UI app. So simply give this app name a default, and we'll update the project name to default. The sync policy I'll set to manual for now. So we can actually tell ArgoCD to manually trigger a sync whenever it finds a difference between our GitHub repository and our existing live manifests. So we have a bunch of different options here that we can configure. Now this is going to match what our manifest is already set to so that the two stay in sync. I'll simply set auto create so that we automatically create the namespace. And now we want to specify the repository URL. So just like we did in our YAML, I'll simply copy over our URL and paste it in. And now we can choose the revision that we want to actually select. In our case, I'm going to follow our existing pattern of selecting the main branch for our revision. And then the path we know is ems/default is where all of our sub apps are going to live. So for our cluster URL, we'll pass in that default one, and the namespace of ArgoCD is where this app will live. Now for directory options, we know we want this to be recursive. And then I'll simply go ahead and click Create to create this application. Now you can see we have a new application that's been created. We can go ahead and click on it. Well, it's immediately going to tell us it's out of sync. And this is because the Git manifests that is generated using our committed default.yaml doesn't match the current Kubernetes cluster that it's connected to. And this is of course true if we run kubectl get applications in ArgoCD, which is where we'd expect this app to live. Well, we see we have default, but it is out of sync. And we can see this if we click on the diff, we can actually see the diff between the existing manifests and the manifest defined in Git. In our case, we set prune and self-heal to true. However, that wasn't set in the UI. So now we can see it wants us to reconcile these differences. And now we can do this by simply clicking on the sync button. Then you can click on the synchronize button here. We have all of these different options to how to actually apply the sync. In our case, we'll stick with the default and click on synchronize. So now we have this app of apps running in our cluster, and it is fully synced and watching for changes to our GitHub repository on these manifests. So now if we create a new application in this m/default, which is where it's watching, we'll actually be able to see these changes now in the ArgoCD dashboard. Finally, you can see if we run get applications again, we can see our default app is fully synced and healthy. So now we're ready to add sub apps inside of this app of apps. So let's go ahead and start with something simple. We'll go ahead and deploy a Redis cluster inside of our Kubernetes cluster and have it fully managed by ArgoCD with this GitOps app of apps model. So to do this, I'm going to simply create a new apps folder inside of default because we might have several apps running. We want to separate them out. Then I'll simply go ahead and create a redis.yaml, and now we can provide the manifest to ArgoCD that it needs to actually run a Redis cluster. Now this is going to be very easy to do because of ArgoCD's out-of-the-box native support with Helm. So we can simply provide ArgoCD with a Helm chart, and it will automatically deploy this Helm chart and keep its resources synced to our Kubernetes cluster. So let's go ahead and implement this. I'll go ahead and copy our existing manifest for default.yaml and paste it in to redis.yaml. So this is still going to be an ArgoCD application. However, now we'll call it Redis. It's still going to live inside of ArgoCD, this actual application manifest. However, the namespace where we want to install Redis into, I want a new namespace for this, and this will be called Redis namespace. We'll keep the project and Kubernetes server the same. However, now for the source, so instead of supplying a GitHub URL now to actually point to other apps, we can now supply a new source of type chart. So chart is going to be the actual name of the Helm chart that we want to download. In our case, it's going to be Redis. And I'm going to provide the chart URL now in the form of the repo URL. So the repo URL is where your Helm chart is actually downloadable from. In my case, I'm going to be utilizing the Bitnami Redis Helm chart. So I'll simply add in the Bitnami charts URL, which is https://charts.bitnami.com/bitnami. So this is going to go ahead and actually download the chart from the chart repository and download the one with this name of Redis. Finally, we need a target revision. Just like the GitHub source, this is going to be the actual version of the Helm chart we want to download. In my case, I'm going to use 18.9.1. You can feel free to use whichever you prefer or is the latest. We can keep the sync policy and sync options the same. Now we have everything we need to actually deploy Redis into our Kubernetes cluster. Again, thanks to this default.yaml that's actually pointing to m/default and looking for any other applications. In our case, we know that this is going to be picking up this Redis app we've just created and set up to point to this Bitnami Redis Helm chart. So now the next commit we make to include this new app should show up in our ArgoCD as a diff. So let's go ahead and do this by committing our changes to our GitHub repository. So back in ArgoCD UI, I'll go ahead and refresh. And if you haven't seen your changes updated, you can click on the app of apps and tell it to automatically refresh by clicking on the refresh button. So by default, the polling interval by ArgoCD on our GitHub repository is 3 minutes. So after we push a change, it's going to take 3 minutes for Argo to automatically detect and sync our changes from GitHub. We can change this if we'd like, but the default is fine for now, and we can just manually refresh to pick up the latest from GitHub. As soon as it did, you can see that we automatically synced thanks to AutoSync. And in doing so, it's actually created this new Redis application. So if we go back to our applications dashboard now, we can see it's tracking this new Redis Helm application. So if we click on it, we can see this really nice visual map of all of our Helm resources associated with this Redis application. And we can see it's currently in the process of still rolling out as it's deploying some pods. However, this is great because we can see how easy it is to deploy this Helm chart with ArgoCD. And the best part about this now is if we run kubectl get namespaces, we of course see this Redis namespace we just created. If we run get pods in Redis, we can see our pods running. So let's say, for example, I was debugging and I accidentally deleted this Redis namespace. Well, in a normal circumstance, this is really bad. It might be hard to get back to our exact configuration that we set on this installation since we've just deleted this. So we have no more pods in Redis. However, thanks to ArgoCD, we can immediately go back to our UI and see that Redis is detected out of sync, and it's immediately auto-synchronized the cluster back to creating this Redis namespace and the resources in it. So now if I run get pods, you can see it's already started to bring up new pods because auto-sync is enabled, and it's trying to make sure that our cluster matches exactly what we've set up in our GitHub repository. So you can really see the power of ArgoCD in this circumstance, where it's able to maintain all of our Kubernetes cluster in version control like this, which is excellent. All right, so next up, I want to show you how we can actually override values that we provide to Helm Charts managed by ArgoCD. So I've gone ahead and opened up artifacthub.io and looked for the actual Bitnami Redis Helm chart that we're utilizing. Now, the reason I've done this is because we can actually look through these docs here and see all of the parameters that we have access to in order to actually customize our Helm installation. So these are different configuration parameters that are provided by default in the values.yaml for the Bitnami Redis Helm chart. So in order to test this out, let's go ahead and update our replica.replica count. So by default, this is the number of Redis replicas to deploy, and by default, it's set to 3. So let's go back to our M's default apps and into our Redis application, where we can override this directly in our manifest here. So to do this, I'm going to go ahead and now specify a new Helm option inside of our source block. So inside of this Helm block, we have the ability to provide values files from either the chart that we're pointing at or any other GitHub repository. We can also provide values directly in this application manifest, which is what we're going to go ahead and do. So let's go ahead and do this by now having a values block, which will set equal to a continuous string. And now any values we provide here will automatically be provided to the underlying Helm chart. So we know we want to override this replica.replica count key. So let's copy this and go back to our Redis YAML. And now we'll supply this replica : inside of replica. We know we need the replica count. So this is a map that we're providing, since this is how it is accessed in the values. So let's go ahead and say we want to have 4 replicas running instead. Now, all we have to do to have this automatically update in our Kubernetes cluster is, as you guessed it, simply push this up to ArgoCD and either wait for a sync to happen, or we can refresh our apps to have this values get updated in real time. So let's go ahead and commit this now to our GitHub repository. So now back in our ArgoCD, I'm going to go ahead and refresh the page, and you can see as soon as I did, we quickly saw that our default app was out of sync, and it picked up our latest commit of replica count 4. So now we can go back and see that Redis has automatically picked up this change to the Helm chart values we provided and is actually progressing through this update. We can even see this if we look in the details tab, where we have all the details about this app. We can go to the parameters and see our values that we've overridden. So replica count 4. I'm also going to go ahead and actually run kubectl get pods in the Redis namespace. And now you can see we have 4 replicas running, with the latest one starting 44 seconds ago. So this is excellent. We've shown how we can actually override Helm charts provided by ArgoCD. And hopefully you can see how powerful ArgoCD is in managing our Kubernetes cluster. So this is just one simple application that we've deployed, but imagine you have a complex Kubernetes cluster with many different components and applications. Well, we can keep them all in source control here and make sure we have a consistent state thanks to this GitOps model and ArgoCD. Thanks so much for watching today's lecture. If you'd like to dive even deeper with ArgoCD and Kubernetes and deploy our own custom Helm charts, deploy to AWS, and install an automatic image updater, head over to my site in the description, where you can gain access to this exclusive lecture if you sign up to become a member today. Thank you so much, and I'll see you in the next one.